Shoot. We're going to determine how probabilities are affected when events are mutually exclusive or overlapping. So exclusive looks like this. So if you're using your shapes tool, and we're going to be making some more Venn diagrams today, hold the shift key down. Well, first I need the circle. My keyboard is dead, so I'm limited to where I can move today. Where is the mousey? There's the mousey. Okay, so mutually exclusive. Ooh, interesting. Would look like this. Two circles that are sets that have nothing in common. So this is exclusive. Overlapping is exactly the way it sounds. So we make a Venn diagram. You're going to have two sets where there is stuff in common. And if you look up on the front board, that's something you can use for one of the homework problems. So overlapping, they have stuff in common. There's the overlapping part. And if you look over here, this will make more sense when we actually work through that problem. Okay. Exclusive, nothing in common. So in the Venn diagram. In fact, most of the time, if it's exclusive, I wouldn't even bother with a Venn diagram. I mean, if there's no overlapping, there's really kind of no point in putting that in there. Okay. Sam. All right. So, two events are mutually exclusive if they do not occur in the same trial of an experiment. Let's make a text box. Do not. D-O-N-O-T. Or if you like the contraption, you can put don't. Bless you. So it's really easy to find the probabilities of one or the other because we just add them together. When they have overlapping, two events are inclusive or overlapping if they have, well, I won't even use fancy math words, something in common. And that'll make, oh, hello. That'll make more sense when you start doing a problem or two. And notice you have a different way to find the probability. Basically what it boils down to is we can't count stuff twice. And this will make more sense when we do that first problem. Probably a second problem. First problem, not so much. All right. 12-sided die, a dodecahedron. So numbered 1 through 12. What's the probability to roll a cube and result is an even number or a 7? Let A be the event you roll an even. And B represent roll a 7. So even. And then this is 7. And then down here, I will make a text box representing A for the one on the left. So caps. Tab, 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 tab. B is one on the right. Move this down a little bit so you can see a bit better. Okay. And then we will populate each. So 7's easier. Is 7 even? Okay. So it goes all by itself over here. So my even numbers are going to go over here. Come on now. So let's see. I got 2. I got 4. I got 6. I got an 8. I got a 10. That's a 12-sided cube. I got 12. So really, this isn't properly done, right? My two circles shouldn't have any overlap because there isn't any overlap. And then even though that's just the evens and the 7, we should put the rest of the numbers. Where do the rest of the numbers go? In the rectangle, but outside the circles. So we'll just find some space. Where's my mousey? There you are, mousey. It's so hard to see over here. All right, so let's see. Come on. I got 1. Already got 2. I got 3. I got 5. I already got a 7 on the right hand. I got a 9, and I got 11. And that would represent the entire sample space of rolling a number cube. Okay. So on the next page, you're going to calculate the probabilities of getting an even, getting a 7, getting an even or a 7. Okay? So go to the next page, see what you can do on your own. So calculating the probability of A, remember, is really just calculating the probability of an even number. So even, and over here, this is probability of simply getting the number 7. So come down here, I got 6 evens out of 12. That's 1/12. Sorry. And there's only 1 7. So not so lucky as it is on a pair dice. On a pair dice, there's 6 different ways to get a 7, but on a single die with 12 sides, you only got one way. So let's do this one first. This really should say compare to C. Come on now. So A, 6/12. Notice I wrote it in the non-simplified version because I need a common denominator anyway. Divided by 1/12 is how many 12ths? This is not a trick question. 7/12. Okay. And when it says A or B, in this particular case, since I don't have any overlap, it's going to be the same. Okay. So this is known as mutually exclusive because we don't have any Jiminy Crickets. Okay. 12ths. So at the top, let's make it clear, these are mutually exclusive events because I can't have a 7 and an even because 7 is not even. You learned way back, I don't know, when you learned evens versus odds. 2nd grade, maybe? Something like that. It's been a long time. Even longer for me. So it's either, let's see, I actually know all of my elementary school teachers' names still. Well, my first one, she was a neighbor. That was Mrs. Weingart. She ended up being a principal a few years later. Then Mrs. Wise, Mrs. Craigman, Mrs. Lipinski. And Mrs. Lipinski in 3rd grade, if you had anything in your desk, she'd check them every week. And we had these 2 kids, Jamie and James. They were quite the pair. They had these little cities inside their desks. And she was so mean, she'd literally take the desk and flip it and tell them to clean it up. And there was Mrs. Smith, Mr. Ryan, and then I always get her, can't always pronounce her name wrong, Mrs. Valenzuela. Okay, that was my elementary school experience. All right. That was back in the 70s. All right, this one's a little different. It's still evens, right? This is still even. So let's go ahead and label these. So I'm going to put the labels underneath. Of course, I need a text box. So evens still, but over here, this is greater than. So I'm going to get fancy. I put a greater than sign. So up here, it's still going to put A and B. So A, B. This is still even. Go back off the cap lock, even. This is still a 7. So this time we're going to have some overlap. So first thing you should do is put the overlap pieces. So what are the evens that are greater than 7 and put them right here. So I make a text box kind of towards the top and just work vertically. Okay? So take a few moments. Put the evens greater than 7 in the middle, the rest of the evens on the left, and the rest of the numbers bigger than 7 that are not even in B, and then anything else is going to go on the outside. Okay, so I'm going around. Most of you are in a pretty good space. Start here. My evens bigger than 7. Nick? How about 8? Yeah, 8. I'm sorry, I didn't hear the 8 part. And then over here are the rest of the numbers bigger than 7 that are not even. That would make them odd. Is 7 bigger than 7? No. So 9, 11. So what goes over here on the left? 2, 4, 6, because they're evens that are less than 7. Okay. 2, 4, 6. Okay, I'm going to introduce a new topic, which we'd see a little later, but I thought this is an appropriate time to discuss it. I want you to type the word complementary. Where you normally see an I, make it an E. So complementary. Complementary. You might have remembered this from geometry, but it has a different meaning. But it's similar to what's going on with the geometry meaning. Anybody remember what complementary angles are? Add up to be 90. Okay. Supplementary. Okay. So complementary events. Okay. Combine to make a whole. To create the entire sample space. Okay. So in this particular case, we want the complement of something being even or odd. So I'm going to write it in words and then show you what the symbol looks like, and then we're going to find out what that space is. Okay. So if we have not even or greater than 7. So that would be the complement of what we have up here already. Okay. So the way we'd show this would be the following. It's going to look a little weird. Okay. Make a parenthesis. Actually, let's use our equation editor. So make a parenthesis, capital A, then the U. So remember, when the equation editor, you're going to need the little pi symbol up here. And if you go all the way to the bottom, you start seeing musical notes. Whoopsies. We don't want the musical note. We want U for union. I don't know. These people in New Zealand, I guess they there is a lot of overlap between math and music. So we're not using the musical notes, but we're using the U. And then B, and then close parentheses, and then shift 6 like you're going to do an exponent. What does the word complementary start with? C. So you're going to use a lowercase c. Okay. So the complement of evens. So what would that actually be? What's the complement of even and greater than 7? Little bit of c. Yeah. What's the complement? What would this actually be? Is there another way to say not even or greater than 7? Odd and less than. Okay. So we're looking at odd numbers less than 7. Okay. A little less awkward than not even, right? So odd numbers less than 7 are going to go inside the sample space, inside the rectangle, but outside the circles. Get some lines to make a little more sense now. Okay. So what are my odd numbers? 1, 3, 5, 7. Actually, this would be, let me rephrase this. This is less than or equal to. Yo.
What's that thing in the middle of A and B?
That is U or union. It's just kind of a fancy U. It flattens out at the bottom. So 1, 3, 5, 7 going outside. 1, 3, 5, 7. So now that you have all the information you need, go to the next page and answer the probabilities. Take a look here. A is not just those numbers. Okay. A is all 6 of these. So probability of A are all of your evens. Probability of B are all of your numbers greater than 7. So I got 6 twelfths and 5 twelfths. So on the next page, this one's 6 twelfths or a half, but I'm going to leave it as 6 twelfths because we're going to have to do something with a little lighter. And I have 5 numbers bigger than 7, 8, 9, 10, 11, 12. Okay. A and B is just the overlapping numbers. So those are just these three. Oopsies. That's the 8, 10, and 12. Eraser. Okay. So that's 3 12s. 3 12s. And then A or B. Come on. There we go. We have the 6 plus the 5 minus my overlapping pieces, because I can't count the numbers twice. We have numbers that are even and bigger than 7. Minus 3, Control A, subtraction, divided by 12. And we can prove this by looking at the inside. We'll see. So A or B, 6 plus 5 minus 3 is 8 12ths. And this time we will simplify. That's 2/3. Okay. The 2/3 of my numbers are either even or greater than 12. And you can confirm this. Just count up top here. Let's go green. 1, 2, 3, 4, 5, 6, 7, 8. That's it. And then I'm going to come back here and let's simplify that to make a half. That's it. Take a look at this one. Okay. First thing I want you to do is write this in words. Probability of senior plus probability of girl minus probability of a senior girl. Write that word. Write those words. Probability of senior plus. Okay. So text box. Capital P. Parentheses senior. So that's all the seniors. Plus, I'm going to put a space here. Probability of all the girls. Not Gurks. I'm sure Gurk is something in some weird game. Oopsies. Minus probability of your senior girls. Take a few moments. And this is a contingency table, but we can also use this for mutually exclusive and inclusive. So underneath the words, make an equation box. Take a few moments. What's the probability of being a senior? What's the probability of being a girl? And then subtract out the probability of being a senior girl. What's the good news here? Unlike the contingent tables before, our denominator will be the same. What's my denominator going to be every single time? 808, because that's the total. Okay, so go to my drawing. So all of these are going to have fractions. So I'm going to set up the fractions. So I have a fraction, 808 on the bottom. I'm going to put a plus, another fraction with an 808 on the bottom. I'm going to go a minus, another fraction with 808 on the bottom. All you got to do is figure out the numbers on top and then subtract. Go for it. 202 seniors. We've got 412 girls. And we've already counted the seniors. Whoopsies. We've already counted the seniors, and we've already counted, those are girls. I already counted the seniors. What we need to do is, since we've counted the senior girls twice, we need to subtract them out, okay? So that's why we put that minus piece in there. So we have to subtract out the overlap so we don't count them twice. And then Control A, Control C, go to Desmos. Haven't done this already. Control V. And then simplify your fraction. Do not give me a decimal unless there's decimals in it or the problem. So 253 404ths. The default is, if it's not asked for, you don't have decimals in the problem, your answer is a simplified fraction. 253, 400 fourths. Definitely more than half. Okay. Questions? All right. Last one. I'll set you loose and you can get whatever you need to get done tomorrow. Review. Write a test. Okay, here we go. Probability domestic or late, same process. All the domestics, all the lates, and subtract out the domestic lates, and see if you can figure out that part. We just talked about complementary. Okay, so see what you can do on your own. Last one. You know, a couple minutes, try to figure this out on your own. P, whoopsies, what happened? There we go. Probability, you have a domestic flight. What's domestic mean? They're only flying where? Inside a country. International means flying outside. So if you try to go to the airport and try to get on a plane to, I don't know, Switzerland, Mexico, Australia, and you do not have a passport, they will say, bye-bye, come back. And I don't know, 2 to 3 months, it's how long it's going to take you to get that passport. You don't have to have it for 6 months before you fly. No. What's that? Well, it depends on where you're at. Well, to go to Mexico, that might work. Go overseas, not going to work. You want to go fly anyplace else? Like around here, it might work. Okay, so to fly, you mean flying? See live? You got a spot in the back of your ear there, AJ. There you are. All right. Take another few moments. Find out what's the probability domestic, probability late, and then subtract out your domestic late flights, or I guess late domestic would probably be better. So let's back this out. I think late is a better adjective. Sometimes you can use words as both an adjective as noun, but I think domestic is better. Okay. All right. Take a few more minutes. Okay. It's not as big as like, I don't know, JF Kennedy or some places back east, but still, or LAX. So how many C? Domestic is 120. We have late flights 18. And then the late domestic flights, all you do, this is really simple. You go this way, you go this way, and where they cross is the number that you are looking for. So in this case, 12. Because we've already counted those 12 as part of the late flights or domestic flights. So if you simplify that, you get 7/10 of your flights. Okay. Probability of domestic or late complement would be all of the international flights that are on time. So another way you could write this is probability international and on time. International, internation is probably a word, I don't know. And on time. So in this case, all I need to do is look for that one place. So international and on time, and that's 54 out of 180. 54 180ths. But you know what 54 180ths simplified to? 3/10. What is 3/10 plus 7/10? 1. So another way you could do this, make a little text box. Text box. Complementary events have probabilities. I hate typing one-handed. Geez, that add to 1. So I could have done this another way. 1 minus 7/10. So if I didn't know that this was international and on time, I could have just said, well, I know that this is 7/10. This is 1 minus 7/10. And that is 3/10. So I don't have to understand this piece. Although on a test, I might ask that part. Aiden, why is that thing in your ear? Thank you. Okay, questions? All right. That is it. We are done.